Good evening. Good evening. Am I audible?
Yes, ma'am, you are audible.
Okay, thank you. So I'll share my screen now. Welcome to this Environmental Chemistry Week 2 problem solving session. This course is being offered by NPTEL, and I am Manji Tripathi. I am IIT Madras Research Scholar. So I'll be helping you in solving the doubts related to week 2 of environmental chemistry. So this is the recap. We learned about component balance, various reaction kinetics, type of reactors, and we also learned about the mass balance that we use in different kinds of reactor. So in the component balance, we learned about how to balance equations, chemical equation. So what is chemical equation? So chemical equation is in which some compounds, some bonds are broken and some bonds are formed. So the number of bonds or the number of component in each side of the equation, like if five compounds are there before bond is broken, and how so equal number of bonds or compounds should be there when some other bond is formed or broken. So like that we need to do component balance, so we balance equation. Other thing was reaction kinetics, we studied about this also, and the type of reactors. So all the chemical or biological reactors, all kinds of these kinds of reaction happen in a reactor. So this reactor can be a real reactor or some hypothetical situation. So different types of reactors are there, like batch reactor. So I'll give you a few examples. Other than this also there can be different reactors. So batch reactor, some continuous flow stirred tank reactor, and one is plug flow reactor. So we assume that all kinds of reaction happen in some or different kind of reactors. So these reactors can be hypothetical as well. For example, if when we talk about a lake, so we assume is it as a continuous flow reactor. So in this reactor, what happens? The assumption is that the water or the compound which is inside, it is completely mixed. There is no corner which is untouched. So there is no dead points or anything. So it is completely mixed. So we assume lake as this kind of reactor. But in actual scenario, what happens? There will be some dead corners in the lake. So for example, if we see the surface of lake, in the sides we will see accumulation of leaves, uh, plastics that we have thrown. All these things we see towards the sides, but in the middle, those things are not there. So it is not, from the top view also, it is not homogeneous. So it means it is in actual scenario, it is not following this completely stirred flow reactor thing. Okay. But we assume lake, for simplicity, we assume it like that. Similar case for rivers when we talk about plug flow reactor. The next thing we learned about is mass balance. Okay, so it is also related to component balance. So whatever is destroyed in one part or created in the other part, it should be balanced. So in the reactors also, the equations that we got for the reactors, it is following the mass balance approach. So if you want to solve any system at equilibrium, okay, so what was equilibrium? After some time, the number of bonds which are broken should be equal to the number of bonds which are forming. So this is the position at equilibrium. So how we can solve something at equilibrium? We need certain equations, certain number of equation and certain number of unknowns to solve a problem. So from where we will get all those equations? One is mass balance, charge balance, we will have equilibrium equation, and we will use component balance also. So if we want to solve a system depending upon number of variables, we need as we know that number of variables should be equal to number of equation to understand the system. So from where we will get this equation? These are the approaches: mass, charge, equilibrium, and component. So other things are very common, like mass balance. We also know that there should be balance between the positive and negative charges. We also learnt about the equilibrium equations. But what is how to solve this component balance equation? So first of all, there were steps. This you can click a picture of this slide because it will help you in solving the problems that we are going to see in the program. So first we need to identify species at equilibrium. Okay, we need to identify there is a difference between component and species. So we need to first identify the species at equilibrium. Then we need to identify minimum number of components to form all those species. Okay, how many components are required to form that particular species, especially when we consider water. So for preparing water, we need either H plus or OH. So depending upon that, all you need to choose. Then we need to write the formation equations. Then we can prepare a tableau and then we write equations for the component in terms of species using tableau. So this is the basic line of component balance. We studied about reaction kinetics also. So we know what is reaction kinetics, how fast the reaction is, how fast the reaction is moving. It can be studied by reaction kinetics. Okay, and what is reaction equilibrium? That how far the reaction can go. So that is extent of reaction. So that is equilibrium. But when we talk about kinetics, it is that how fast the reaction is going. Also, there was different characteristics. So it is a characteristic property of a reaction. Then how can we study the rate of reaction? Either we can describe it by overall rate or volumetric rate. Apart from that, we studied about sequential reaction. So two reaction can happen in parallel. For example, A and B, A plus B is forming some C, and let's say one different reaction is there, D plus E is also forming some C. So these are dependent but parallel reactions. And what is series reaction? A is forming B, which in turn is forming C. So this is reaction in series. So we studied about this also. So these kinds of reaction happen in nature. In series reaction, there is one example of conversion of ammonia to nitrite, then nitrate. Then we studied about rate constant. So what is rate constant? Okay, so we studied about that as well. So there will be, for all these reactions, there will be different rate constant. For this, it can be K1, here it can be K2. So similarly, for rate constant for other equations also. Then we studied about rate limiting step. So this is very important. Actually, this only tells that how fast the reaction is going. So what is rate limiting step? the reaction, the step which is slowest, it is called rate limiting step. Also, we studied about there is effect of temperature on the reaction kinetics. For some reaction, if the temperature is higher, the reaction will be fast. And for some reaction, if the temperature is lower, then the reaction will be fast. Okay, but for most of the feasible reactions, the rate increases with the increase in temperature. So we can solve this by Arrhenius equation. Second, the reaction can be, there are different characteristics of reaction. Some reaction can be reversible and some can be irreversible. Okay, so the reaction are kinetically controlled and equilibrium constant is higher for irreversible reaction because it cannot go back. So that's why equilibrium constant, which is in the form in which the reaction is written. So if A is changing to B, then equilibrium constant from A to B, if it is very, very high, then there is very less chance that B will get back to A. Okay, so if the reaction equilibrium constant is low, then it means it is going in either direction. And what is rate of reaction? It depends upon concentration of reactant only. Equilibrium constant, it depends upon concentration of product and reactant both. Okay, I'll write it down. Equilibrium constant depend upon product and reactant both. However, the rate of reaction, it depends upon concentration of reactant only. So I hope you remember when we say concentration, we actually mean activity. So these are curly brackets. So we actually means activity. But for simplicity, we consider activity and concentration as similar thing. But as we studied in week 1, we actually mean activity. But if the solution is very, 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 very dilute, then this activity and concentration will be similar. So these are the equation for different type of reactors. So reactors can be, as I explained earlier, batch reactor. It is completely mixed and closed reactor. Closed reactor means now you cannot put anything when the reaction is going on. You, like for example, take a beaker and fill it with some chemical, let's say H2SO4, and the rest of the things you are putting is water, and now you are not putting anything. So the reaction which will go on between and for information, that will be exothermic reaction. The reaction which will go on for a very short period of time. At that time, that reactor is batch reactor because we are not putting anything and we are not taking out anything. Second is completely stirred tank reactor. So it is also completely mixed. The example of lake that I gave you, and it is not closed because, for example, in lake also, it will receive various outfalls from treated or partially treated wastewater, sometimes treated also. It will take agricultural runoff and it will take rainwater as well. So it is not closed system. So this is the equation for the completely stirred tank reactor. And the third is plug flow reactor. Here the concentration changes with distance. So it is like for a river, the concentration at point A and point B will be different. Okay. So this is plug flow reactor. The concentration at these 2 points, point A and point B. So concentration at point A will not be equal to concentration at point B. So it means concentration is changing with distance. However, there is one assumption here that the concentration across the cross section, it will be same. Okay, but in actual scenario that does not happen. Okay, for example, if we take a river, people living this side will experience different quality of water than the people living on this side. So this plug flow reactor concept also is not completely applicable in the lakes or any river. So these are hypothetical systems. However, how we assume that we will, for example, if we are taking river, we will divide it into small strips. Okay, and each and every strip will be considered as a plug flow reactor. So these strips are very thin. So the concentration across that strip will be similar. So this is how we consider and solve river problems. But for now, at your level, it will be enough to take this whole river as a single plug flow reactor and solve it. So coming to question number 1. So consider the dissolution of sodium bicarbonate in water. What is sodium bicarbonate? Right, NaHCO3. NaHCO3 in water. Species at equilibrium for the above dissolution are H plus, OH minus, H2CO3, HCO3 negative, CO3 2 negative, and sodium. Which of the following groups can be chosen as component for formation equation? One or more options may be correct. Okay. So you need to choose the correct option. You can answer in the chat box. Okay. Other people? Okay. We'll see the solution now. So the correct option is option B and D. Okay. Why A is not correct? Because OH and H plus both are there. But how do we consider it? We consider H2O as one. So, like if we say OH and H plus both are there, we can consider OH as, I'll show you. OH can also be written as H2O minus H plus, right? So that's why both of them we do not take H2O minus H plus. So either we can take H plus or OH because H2O we know. Okay. So we do not want to increase the complexity of the equations. We do not have that many number of equations to solve all of them. So that is why H2O minus H plus can be taken as OH. So that's why we are not taking A, and B and D are the correct answer. Note this down. We'll see the solution. Okay, I hope you understood why C is not correct answer. Because for making HCO3 2 negative also, just H2CO3 minus H plus can be there. So what are the species? It should be completely independent of each other, and if we combine them, they can form the other species. Please note this down. We'll move forward to the next one. Coming to the next question. Sodium acetate is dissolved in water to undergo the following reaction. Okay, these are the reaction, and we know the species and component. Choose correct options for total concentration of component. So there will be two correct answers here, one for sodium, one for acetate. It can be more than two also. Okay. What will give the total concentration of the component? H total, sodium total, acetate total. We know the species, component, everything. You need to prepare the tableau. Then you can get the correct answer. Write component as rows, species and column. Similar kinds of question are there in assignment also. Okay, I'll give you the solution, then try. Okay, so B, C, D are correct. Check with your answer. Check with your answers. I'm also doing it. I'm using mouse to write in my monitor. That's why my handwriting is coming like this. Sorry for that. Okay. Then when we see Na in this equation, other component can also be there. Na is the total. So for Na, 1 and other things are 0, 0, 0, 0. When we say H plus, then this 0, and we can get 1 from here. This will be minus because H2O minus OH, HAC, we will get 1. Okay. And for AC, what will be? This will be 0. This will be obviously 1, 0, 0, and 1. When we will simply add this, for Na, we need just this Na plus. So B is correct. When we see AC, when we see AC, we need what? 1 AC and 1 HAC. So AC correct. And when we see H, what do we need? We need H plus minus OH plus HAC. So this is correct. So B, C, D are correct. We need to make W and check the result. So this is next question. A sequential reaction is there, means reaction in series. It is 3-step process. K is being converted to B, B to C, and C to D. And we have K1, K2, K3. So which step is the rate determining step? Which step is the slowest here? Okay, K1, K2, K3. Which step is slowest here? So this is a very simple question. You can answer in the chat box. Okay, other people? I would give a hint here. Option C is not correct. Think a bit more. A little bit of mathematics is involved here. Okay, I'll show the answer. So the correct option is option B. As we see, if we see, if B is being converted to C, let's say it is taking 1 minute. Okay, So B to C. So K2 is taking 1 minute. Okay. How to explain this? Okay, let's say from if 100 number of B is converted to C, 100 number of B is converted to C. Okay, I'll explain it like this. Let me clear it. Hmm. Uh, the time taken for B to convert to C is, let's say, um, let's consider the reaction is occurring in 1 minute. Okay, so that is one thing. All this reaction is happening in 1 minute. So within 1 minute, only one B molecule is converted to C. Okay, but 100 A molecules are converting to B. Within 1 minute, let's say in 1 minute, one B molecule is converted to C, but 100 A molecule are being converted to B and 100 C molecule are converting to D. Okay, I'll explain like this again. If people are running in a race, this is A, B, C. Okay, so what is happening? B is taking only one step. It is coming here, and at the same time, A is taking 100 steps, and C is also taking 100 steps. So this is what it meant by this. So if the speed of B, if the speed of B is x, or whatever given here, if the speed of B is k2, speed of A is 100 times of k2. So A is 100 times faster, and speed of C is also 100 times of k2, 100 times faster. So that is why we can say B is the slowest step. Okay, because other speed is 100 times faster than k2. Like that, like a race wheel, we can understand this. I hope you understood. We'll move forward. You can stop me if you have any doubt. You can post questions in my website also. I can address them later if you want more discussion on this. So coming to question number 4, which of the following statements are correct? There is one reaction. A is being converted to B. So which of the following options are correct? We are talking about irreversible, reversible thing and the rate determining step. What is the rate determining step? Slowest or fastest? We just discussed it earlier. So what will be the answer of this question? Try to solve this. Okay, we'll see the solution. Option A and C are correct. So first of all, we know that the rate determining step is the slowest step. Okay, this thing is important because if we talk about this previous question, yes, A is 100 times faster than B reaction. K1 is 100 times faster than K2 and K3 is also 100 times faster than K2. So let's say A is converting to B 100 molecules. Okay, 100 molecules are being converted to B, but B is able to convert to C only one molecule. Yes. Am I audible? Yeah, I just lost my internet connection for a while. So I was saying A is being converted to B. Yeah. A is being converted to B. 100 molecules of A are converting to B. But from B to C, because if it is slow, only one molecule is converted. So if C, even if C has speed 100 times more than K2, but what will happen? Only one molecule of C is being formed, right? So even if the speed is, it can convert 100, it will be able to convert only and only one. Okay, so overall, what will happen? Overall, the final product D, we will get only one, even if it can convert. We will keep on accumulating B because A is being converted to B, we will get every time 100, 100, 100. But here only one. So in next step also only one. So overall, what we will get? One. So why this is happening? Because of this particular reaction from B to C. So because of this particular reaction, this is happening. Okay, reaction B to C. So this is slowest step. So slowest step is rate determining step. So that is why C option is correct. Now for A, for the reaction to be irreversible from A to B, RB has to be much greater than RA. Means rate of formation of B, if we want to make it irreversible, means B is not converting to A. We do not want that. So RB should be much and much greater. The rate of formation of B should be greater than rate of formation of A if we want this to be irreversible. Okay. Reaction going faster in forward direction and slower in backward direction only makes the overall reaction irreversible. So this is next question. 1 gram of solid calcium sulfate is added to 1 liter of pure water. Okay. Some of the solid then dissolved according to the following reaction, which has equilibrium constant of K is equal to 10 raised to power minus 4.85. Now the concentration of calcium at equilibrium is 10 raised to power minus x mole. Find the value of x. We have been giving the concentration of sulfate here. So what will be, and important thing is here we are considering activity is equal to concentration. Okay, so you do not have to worry about the activity. You can just consider it as concentration and solve the problem. So try to solve this problem. This is a very simple one. You have to just write K is equal to product upon reactant and you'll get the result. Try the problem. Is there anyone who got the answer? Ashish, please mute yourself. I'm trying to mute you. Has anyone got the answer? It is very simple. K is equal to product of product divided by concentration of reactant. Okay, we'll see the solution. We know that it is given at CaSO4 is a pure solid, so that is why the concentration or activity will be 1. For sulfate, it is 10 raised to power minus 7, and K is equal to product divided by reactant. So Ca2 plus into sulfate 2 minus divided by CaSO4. CaSO4 we know is 1. So Ca2 plus into 10 raised to power minus 1.87. And what is K we have? 10 raised to power minus 4.85. Then we simply got the answer. Ca is equal to 10 raised to power minus 2.98 molar, which is our answer. So we needed to find the x, right? So x is 2.98. Okay, please note this down. Move forward to the next one. Coming to next question. A study that investigates the reaction of bisphenol A with hypochlorous acid revealed that even if all the BPA reacted, hypochloric acid would decline very less and could therefore be treated as approximate constant under the experimental condition. Okay, so here this whole reaction, even if two components are there, BPAN and HOCl, this whole reaction will be first order. Why? This is called pseudo first order reaction, in which the other thing, one of the reactant is not changing at all. It is like infinite, so it is not changing. So even if two reactants are there, we will call them pseudo first order reaction because it depends upon concentration of just one component. Okay, so this is similar kinds of reaction. The rate expression is given. The initial concentration of 0.3 micromole per liter total BPA and 18 micromole per liter total hypochlorous OCl. It is not hypochlorous at pH 8, and the Kf is 150 liter per mole per second at this pH. What pH 8? How much time would be required to destroy 75% of BPA in this solution? Okay, try to solve this question. This is little tricky one. Try to solve. We'll see the solution, but it will be good if you use calculator and try to solve these questions. You can use calculator for faster computation. Other people? We'll see the solution now. So the equation R can be written as minus K BPA HCl. We know that HCl will be very high. HCl will be very high. So HCl will be equal to OCl because it is not changing, right? It is not changing. So HCl, what will be the actual reaction? This HCl, it will convert to H plus OCl negative, right? Don't mind my handwriting. I'm using the basic mouse with my basic laptop. So this will be the reaction. But as in the question, it was told that hypochlorous acid would decline very less. So it means it is technically, it is not at all being changed. It is not at all being changed. So OCl and HCl will be equal. So in place of OCl, in place of HCl, we can write 18 micromole per liter. Okay. So since important thing is here we need to consider the units. It is micromole per liter. So but all these things are given in moles per liter. So we need to convert micromole to mole. That is why we are multiplying 10 raised to power minus 6. Okay. And simply we will get R, which is this. So R is what? It is rate of change of BPA with respect to time. And we will solve this differential equation. We'll get this, and simply while solving, okay, 75% of BPA is being changed, means BPA divided by BPA naught will be just 25%. 100 minus 75 is 25, which is equal to BPA naught e raised to power 0.0027t. And just that is why I was asking you to use calculator, because these are anti-log calculations. This can be easily done in any scientific calculator. So you will get 8.56 minutes. Please note this down. So we'll move forward. For these classes, it will be better if you sit with calculator. And maybe after this or this week, all the questions will be solved in Visual Mintech. So it will be better before coming to class, you download Visual Mintech so that when sir will teach, you can solve along with him, and it will be easier for you to solve in the doubt solving sessions also. So keep this scientific calculator and Visual Mintech handy all the time. So please keep yourself mute. I'm muting you all the time. You're unmuting yourself. Okay, we'll move to the next question. Question number 7 is, it is simple question. Which of the following class of reactors can be used to model calculation of 70 BOD of wastewater in a beaker in a laboratory? We are talking about a condition in which a laboratory based condition, not a real scenario, so that the reactors can be easily taken down as that particular reactor. The theoretical reactor and the laboratory based reactor are similar here. So, how can we consider this beaker in the laboratory for a 5-day BOD test? What kind of reactor can be considered? Plug, batch, or completely mixed? This is very simple. Yes, correct. So, that will be batch reactor, because one, we are using beaker, so we can completely use a rod and mix it. Okay, so it is completely mixed, and 5-day BOD means 0th day we are adding something and leaving it as such for 5 days. We are not at all touching it. We are not removing anything. We are not putting anything else. So it is a closed reactor. So that is why it is a batch reactor. Okay. This is question number 8. Consider the following reaction occurring in a reactor. A plus B is being converted to 2C plus 3D. Rate of reaction is R1, and 3C plus 2B is being converted to A. So what will be the net rate of formation of C? Okay, in first reaction C is being formed, and in the next reaction C is being consumed. So what will be the net rate of formation of A? Correct answer is 2R1 minus 3R2. It is very simple. When we say rate of formation, so here C is forming, so that is why it will be R1 will be positive. And here, because 2 times of C is forming, so 2R1. Very simple. And here C is being consumed, so that is why we will see a minus sign here, and 3 moles of C are being consumed, so that is why minus 3R2. So that is our correct reaction, 2R1 minus 3R2. Such questions are very simple. Just note it down. It is being formed, so that is why positive signs with multiplied by number of moles. And the other reaction, it is being consumed, so that is why there is negative sign with multiplied by number of moles. So here we need calculator. So a batch reactor is operating to treat a toxic chemical X present in water. The initial concentration of chemical X was found to be 500. The concentration of X shall be removed to a desirable limit. So final what we want is 10 milligrams per liter. It is initially 500. What we want is 10 milligram per liter. Calculate the rate constant if the desirable limit is achieved in 10 days. Okay, we know the value of T, we know C naught, we know CE. What will be the T? We are talking about a batch reactor here. We know the equations. So this 500 is C naught. This is desirable limit. This is what we want. This is C, and we have T also. You know the batch reactors formula. Anti-log equation is there. Okay. So that is why you need to use calculators and try to solve this one. Let's see the solution. The answer is 0.391 per day. So please match with your answer and check it again. We'll see the complete solution. So we know that C dot is 500, C is 10. So C is equal to C dot e raised to power minus kT. That is for a batch reactor. We have to just put all the values and we will get K is equal to 0.391 per day. It is very simple formula based question, direct question. So this will be the last question. Answer is also given. So select the correct statement. One or more options may be correct. Diffusion phenomena occurs due to concentration gradient. Yes, very true. Okay, we know that there are different kinds of phenomena by which dilution happens or the chemical reaction happens. Advection, diffusion, dispersion, like those. So in advection, what happens? With velocity, flow will go from one point to another, like we have seen in a river, right? Like river. So if the flow is going from this direction, so the concentration will be different in two different directions, right? So this is why this is happening. This is called advection. With the flow of the carrying fluid. Okay, it is changing. The concentration is changing. This process is advection. And what is diffusion? Diffusion is nothing but concentration gradient. If we are in a room and in one corner, if someone has opened a perfume bottle, the person at the other corner after some time will feel the smell. So this is because the traveling of the molecule because of the concentration gradient. Here concentration is very high, here it is very low. So that is why the fluid smell is coming. So diffusion is based on concentration gradient. Advection, we know it is because of the velocity of the fluid. And only longitudinal mixing is considered in advection. Yes, when we talk about only longitudinal mixing is considered in advection during modeling of plug flow reactor. So here we know, then as I told earlier, in advection in a plug flow reactor, the concentration at point A and concentration at point B is not at all similar. Okay, concentration at A and B are not same. So there is no longitudinal mixing. However, there is a lateral mixing. Okay, lateral mixing means along the cross section, the concentration at these 2 points, point X and point Y, will be same. So why these are same? It is considered that there is a lateral mixing. Okay, so option D is correct. So A, B and D are correct. Okay, but in longitudinal side, in this direction, in this direction, the concentration are not same because there is no mixing. If there is mixing in both the direction, XY also in AB also, then that will be a completely stirred tank reactor. It won't be a plug flow reactor. Okay, so that is why option A, B and D are correct. So that is all for today. Please let me know if you have any doubts. We'll meet in the next session, week 3, same day. Okay, so that is all for today. Those people who are not having any doubt, they can leave the class. Rest of you can stay and ask if you have any doubt. Also, in case you are getting any doubt in between session, you can message me. I will give you my message. I have kept my website in the chat box. You can use this to message me. Okay, there are few messages in the chat box. I didn't check. Um, One question is, ma'am, the recorded videos which are available in the portal, just explaining. Yes, actually this environmental chemistry is very, very vast subject. Okay, so they won't solve problems there. There will be just theory only. So if you have any doubt in a particular question or anything, you can contact us. I am giving you my website. If you have problem, you can contact me personally. Okay, I'll help you in solving the problems. And the fifth question, this one. And this was the solution. I will share these PPTs. That is not a problem. And you people can always message me here, mansi.in. You can use this and message me. So that is all for today from my side.